So we're going to find the critical point on which the function is increasing or decreasing. So notice I can't use a graphing calculator. So in order to find where it's increasing or decreasing, I'm going to take the derivative. I'm going to need to set this equal to 0 and solve for x. So notice that I have a cubic, so I can't factor it by normal style. But what I'm going to do is I'm going to set both of these together, and I'm going to factor out a greatest common factor. So the greatest common factor of the first two terms would be 12x squared. And the greatest common factor of the last two terms would be negative 12. So now I can factor out an x plus 2. And I can use the zero product property. Okay, so I have my critical points at x equals negative 2 and x equals plus or minus 1. So I'm going to do a number line to check where my function is increasing and where is it decreasing. Remember that I need to check where my derivative is positive or negative. And I can use this as my derivative because these are the same thing. So number to the left of negative 2, I'll choose negative 3. So this is going to be a negative, right? Negative 1. If I substitute a negative 3 here, this number is going to be larger, so it's going to be positive. So negative times a positive would be a negative. A number between negative 2 and negative 1 would be negative 1.5. So if I substitute negative 1.5 here, I'm going to get a positive. Negative 1.5 here, again, this number 12 times 1.5 squared is larger. So I'm going to have a positive. So that's a positive. So negative 1 and 1, I'm going to try 0. So 0, that gives me a positive. 0, that's going to give me a negative. And then try 2. So that's going to be a positive times a positive. Okay. So once I check, remember you don't need these points anymore. So it is increasing in the intervals wherever it's positive. So from negative 2 to negative 1 and from 1 to infinity. It is decreasing between the intervals negative infinity and negative 2 and negative 1 and 1.